And I want to welcome you to my AZ900 Azure Fundamentals course. So this has been actually a fun journey for me. It's because one of the things I really like is actually doing things at the foundational level before I really start getting involved in bigger things. And the AZ900 exam is a great foundational exam to learn about the language and the technology involved in the Azure cloud from Microsoft. I went ahead and wrote these study notes while I was actually studying for the exam. I went ahead and passed the exam, not a problem. It was actually really fun exam to take, and I was able to do it from my house using Pearson OnView. The passing score for this exam is 700, so not a bad score, about 70% out of a scoring of 1,000. Who this course is really good for are candidates that have some foundational knowledge but are curious about how those are provided with Microsoft Azure. The big thing on this one is that as you dig deeper into the cloud and you take a look at things, you'll find out that things look a lot alike depending on who your provider is. So understanding the specific language that Microsoft Azure uses to describe things like Cosmos DB and so on will really kind of help you frame this service better when you're working with an employer. This exam is intended for candidates who are beginning to just work with the cloud. So you're new to Azure and you're kind of curious as to how it actually works or what it actually looks like. And this is an opportunity for you, the candidate, to prove your knowledge about some cloud concepts, some basic Azure services, workloads, security, privacy, pricing and support, all those things that you would want to know, maybe some simple questions you would get on an interview as you kind of go through this. Really good for business people to take this kind of course, because then you can become familiar with the general technology and concepts, and you can understand a little bit more as you get into that pricing model and you get into the process of how pricing works within this. And I would also use this as a great way of preparing for other Azure role-based or specialty certifications. And the big reason for that is, the test costs about $99 for a regular. They do have a special $15 if you're economically disadvantaged. These are all good things. The best part about a course like this is that it is a great way of learning how Microsoft phrases exam questions. And when you are taking an exam, the number one problem with most exams is that you don't know how they phrase the questions. So do they phrase them in a way that's easily understood about? How do their distractors work? And they'll try to give you a bad answer or try to get you to click on the wrong thing. And this is a really great way of figuring out how they ask questions. So once you know that, you can go armed into any other exam you do, knowing full well what this looks like. And it will really help you understand how Microsoft puts together an exam and puts together a question. This course is really for candidates with non-technical backgrounds, and I would say your business leaders, your business managers, but also really interested in going multi-cloud. Candidates with a technical background, if say you've already got a certificate in Google Cloud or you've got a certificate in Alibaba or Amazon, this just gives you an opportunity to learn some really cool new words and new ideas, but you'll be able to take your experience in other cloud providers and again, learn how the questions are phrased, and that's a big one. Learning objectives for this entire course. This student will learn the basics and take and pass the AZ900 Fundamentals course. This is a straightforward Microsoft course, very little weird, Microsoft weird in this course, which is beautiful. You're going to learn some good core concepts about cloud computing. You're going to learn about core Azure services, and just the core ones, right? None of the other fun things. You'll get that in later ones. The student, you're going to learn about some cloud computing and delivery service models. These models are the same regardless of where you're at. So you're going to use these same models and service models and delivery models as you kind of go through the whole process, regardless of where you're in the cloud. So this is a good baseline for you to understand some of these good technologies, right? Azure is Microsoft's cloud computing solution. And this is an interesting question that they actually asked. And you can actually go through and click on that link, azuremicrosoft.com, and get a really good idea of what it's all about. Azure just have 200 products and services, and that's really what it is. You're building all these things to build and run and manage applications. You can do this as multiple clouds. You can incorporate this with your Amazon or your Google solution or your Alibaba solution. You can do all these things with it, or just run it in a Microsoft cloud and you're good to go. So essentially what you've got is congratulations. I really think that you are really good in getting started on this. Right, and again, entry-level certificates, a lot of people say, oh no, don't do them. But the good part about doing them is you learn a lot about how Microsoft builds a course. You learn about how Microsoft builds an exam. And that's the biggest reason for doing any foundational certificate, whether it's Amazon or Microsoft or Google or anybody else. Learning how questions are phrased on an exam is really the important part. And the cloud, as I understand it, and as the industry is going, is really one of the most democratizing technologies I have seen yet in my era. And it's going to have a ripple effect worldwide for decades to come. The job market is robust in cloud. There are literally hundreds of thousands of jobs open. They're open globally. So if you wanted to take some interesting jobs somewhere else, there are actually 83 jobs open in the cloud right now in places as far-fetched as Saudi Arabia. You'll find cloud jobs open everywhere, including Africa, Middle East, Asia, United States, the EU. It's just this amazingly cool pool of neat things to go do. And you're going to learn about some of those services here with this course. So thank you very much, and I will see you in the next lecture. Okay, so the first section of the AZ900 exam is really just describing some basic cloud concepts, identifying benefits such as high availability, disaster recovery, and is very generic, but it is 20 to 25% of the exam. So you really do want to pay attention to the idea of these cloud concepts because they're like literally a fifth to a quarter of the exam. So there are some distinct benefits of cloud computing that you want to be very aware of. You want to be aware of things like high availability, the ability of the application to keep on running without significant downtime. So if you lose a region or you lose a zone, there is actually a backup somewhere in the cloud that you will be able to run as part of your disaster recovery or your business continuity model. This is a very standard part of the whole process in terms of building out the cloud. You want to make sure you've got some kind of failover or some kind of high availability plan, whether intentional or by design. This is really where you want to go. Scalability, the increase or decrease of the resources and services used to work on workloads, right? So vertical scaling, scaling up, or scaling out for horizontal. These are two important concepts where you scale up by adding more power to the server that you're running, or you scale horizontally by adding more cheap servers. It's up to you and depending on how you want to do it. So you can either add more resources or you can add more servers. That's kind of part of the process for how you would plan your scalability across the board. Then elasticity, add or remove resources based on demand. This is the gold standard for the cloud, making sure that as your demand peaks, you can bring on more servers or you can increase the server size that you're using. And then as you go back and that peak reduces itself, you remove those services. And that is a big way to save money. That is a beautiful way of architecting in the cloud. And that is a big part of why the cloud is as neat as it is. Cloud agility, and this is the ability to rapidly change an infrastructure to adapt to evolving needs of the business, right? So if your service peaks one month, you can go ahead and scale it back. You know you're going to get a larger bill, but next month, if it drops, you get a smaller bill. And again, it's that whole ability to adjust your business computing needs based on what's actually happening in the real world. You're not over provisioning, you're not over capacity, and you're not under capacity. You're at the right capacity you need to be because of elasticity. Fault tolerance is another big one. Redundancy is often built into cloud services architectures. So if one component fails, you have another one. This is your part of your disaster recovery. This is part of your business continuity process. So that fault tolerance is really important as you go through this. And again, this is why you would build in multiple zones, you would build in multiple regions, you would go and do all those good bits for making sure that your system is fault tolerant and has some disaster recovery or business continuity to it. Economy of scale. The big one is that Microsoft can afford to buy more computers than we could ever hope to in our own private lives or for most of our companies. So the big one on this one is that you can actually rent your services from Azure more cheaply than you can by going out and buying your own hardware. And that's what the economy of scale is. And that you are renting your service, your server from Microsoft, and you're good to go from there in terms of that whole process, right? You make sure that you get some kind of cost savings off of that. But again, Microsoft can do things a lot quicker than you can. So another part of this that you're going to get to is the difference between CapEx and OpEx, capital expenditure and operational expenditure. And this is a big part of how you budget for your cloud computing system, right? So we're used to CapEx. We're used to going out to wherever we go buy computers, buying a rack full of computers, buying the rack, buying the hardware, buying the network, buying the router, the switch, and all the rest of it. And we tend to depreciate those over time. Right, so we'll depreciate those over 5 years or whatever. The business pays for all these expenses up front. We hope that it will work. We hope we're not over provisioning. We hope we're not under provisioning, but we don't know what we're going to get. But we do have all the costs involved with CapEx. We have the server, we have the systems, we have the people, we have the network, we have the data center, everything, including maintenance, including software licenses. All of that is part of your capital expenditure. Now, your operational expenditure is your day-to-day operations, right? And you can put people in here, right? If you have a subscription fee for cloud services, and it's considered OpEx, right? So if you're paying $8.50 a month per person for your Office 365, that's an operational expense. You can pay that as at the end of the year, or you can pay it monthly, depending on how you want to get a discount. Again, the longer you buy for, the cheaper it is. But the idea behind that is you only pay for the resources you need as you need them, right? And then you are charged back on a one-to-one basis, and then you can take that off your taxes on a one-to-one basis. If you spent $100 on operational expenses, you can take $100 off your taxes for that year. So there's no depreciation like you would have with capital expenditures. Now, your accountant is either really going to love that or really not going to like it, depending on how the company's tax structure is done. And that's why this is really important. Capital expenditures, depreciation, you're paying for everything up front, where operational expenditures, you're basically paying as you go. And that's the important takeaway on this one, is that you have a pay-as-you-go model that works really, really well for this, right? So by using the OpEx approach, you're shifting your costs associated with your on-premise data centers to the cloud service provider, right? Once you're done, you only have to be concerned about paying for those services that you actually use every day. There's no more buying physical equipment. There's no more buying data centers. There's no more buying switches, routers, hubs, any of that stuff. It all is coming off as an operational expense every day, depending on what you got. Capital expenses are different, right? Generally 5 years to realize your full tax benefit. OpEx, again, is that one-to-one deduction at the end of the tax year, right? So again, you're going to want to work with your company's accountant on this one. But again, the OpEx model can be more advantageous to the company depending on what their tax strategies look like. And that's the other big thing to understand and go with, is that depending on what your tax strategies look like, that's where you're going to kind of go with this. The other thing that's interesting too, and I like this because this is called the pay-as-you-go model, but Azure calls it the consumption-based model, right? And that you're only paying for the things that you actually use. Pay-as-you-go or fixed price, your provisioning resources depending on what you've got. The thing that's interesting about fixed prices, if you agree to do a certain thing over a certain amount of time, you can get like this crazy huge savings, like 80% off of whatever service you're buying if you agree to a year or 3 years, depending on how you go about doing that. So this is part of your common pricing options for Azure, is that consumption-based model. You're only charged for what you use, pay-as-you-go, or for fixed price. Your provisioning resources, and this could be a baseline resource for you, right? I need a minimum of this to run my company, but then I'm going to go pay-as-you-go for any peaks or demands that I need to have, but my fixed price is for the things that I need to run my company on a baseline. So this is where the consumption-based model is really handy for trying to figure out how you want to budget for your cloud, right? So custom way, a common way to estimate cost by considering workloads on a peak throughput, right? So if you're constantly on these high utilization on your pay-as-you-go model, right, then you may want to baseline that, and you may want to make that a little bit easier for you in the longer run by saying this is my baseline and going fixed cost, and then going on along with that. So comparing your baseline with your peak throughput is a way for you to kind of balance out where you want to go on that consumption-based model. How much do you want to have as your baseline provision? And then how much do you want to work on pay-as-you-go for those peaks and valleys? And that's really part of that consumption-based model. So this is another really good part about Azure, and understanding that cutoff point is really the big part of understanding that pay-as-you-go and fixed pricing model. So that's it for this part 1 of the lecture, and I look forward to seeing you in the next lecture. Thank you. We are are in section 1.2. So the next bit is describing the differences between categories of cloud services. So cloud services really are part of what's called the shared responsibility model. We've got other videos on this about how the shared security or shared responsibility model works. And this is a basic cloud security framework that dictates what the cloud provider is responsible for and what you're responsible for as the business using the cloud. This is the defining relationship depending on what service you use and how you want to get into the cloud itself, right? So the one thing to remember is that you are always responsible for your data, and the cloud provider is always responsible for the physical security of the data centers that house its infrastructure. And that is straight from Microsoft. So that shared responsibility model is basically for all cloud deployment types. Doesn't matter which one you use, you are going to own your own identity and your own data. So you're responsible for protecting your data and protecting the people that access it, any kind of on-premise resources for you and your own data center, and any of the cloud components that you control. And depending on which service you use, whether that's platform, infrastructure, or software, those cloud components are going to be different. Whether you're doing function as a service or something else, depends on what service type you're actually using. You just have to remember that the following responsibilities are going to be always retained by you, and that's the data itself, any endpoints, how people connect, how people authenticate, right, access management, and the account security itself. You'd never want to lose your primary account, because that's generally would be horrible if you did. So basically, the shared responsibility model depends on what services you use. Now, when you're on premise and you're in your own system and you're on your own dime, you are responsible for everything. So it's on your premise, it's in your data center with your people and your servers and your racks and your network. You are responsible for everything. But as you move into the cloud, your responsibilities change. So your risk matrix changes. And that's really important too. You mitigate or you transfer a pile of risk and a pile of other processes over to the cloud provider for that economy of scale. So if you do something that is software as a service, if you do something like Office 365, all of a sudden all you're responsible for is the information and the data that your people make, any devices, how you connect mobile and PCs and other systems to it, and then any accounts and identity, and that identity and directory infrastructure if you use the Azure Directory Sync or some other directory service, right? Platform as a service, you add additional things, you add some network, you add some applications to it. If you're writing your own applications, you share that service between the two. If you're infrastructure as a service, you own all the things. You own the operating system, the network controls, applications, people, data, accounts, and devices, and how all that connects. You don't ever own the physical host, the physical network, and the physical data center. So you're not responsible for that anymore. Microsoft is. And you can actually get a lot of really neat reports on that, whether it's PCI DSS compliant or SAS 70 or SOC 1, 2, or 3. Just depends on what kind of thing you need to have to prove to your auditor that we've got this covered. But the biggest one, again, is that idea that you will always control your own data. And that's a big part of the shared responsibility model. You own your data. The service provider owns the physical network and the hosts and everything else that goes along with that. Some responsibilities require the cloud service provider and the customer to manage and administer that responsibility together. You see that a lot with platform as a service, and that you're sharing things along the way. So when you're considering your identity and access management, when using Azure Active Directory services, configuration of services, and multi-factor authentication, if you're doing functions, if you're doing parsing, or however you're working it, making sure that effective responsibility and effective functionality is on you for your code, but on Microsoft Azure for the underlying platform, and making sure that you have all the pipes and other things that you need to have. So both on-premise and cloud models, you really need to make sure you've got your data covered. Now, whether that's labeled, classified, whatever your obligation is for compliance, that's a whole different thing. Compliance in the cloud is a neat thing. You won't need to know very much about it. You just need to make sure that when you get to that process in the cloud, that you are responsible for your data and how people access it, right? And that can be all you need to know for this exam. But the good thing to remember is that data classification can be complex. It's an important issue, and it's really something you want to consider when you take a look at moving to the cloud. It is really something that you want to be able to bring up and take a look at how you do company confidential, company secret, or otherwise, especially if you're working in federal government or however you want to do things. That data classification is huge in helping determine how your data will be stored securely. So that's it for this lecture on the shared responsibility model. It's a really interesting concept, and there's a lot of neat things that are going on with it right now. This is by no means a fixed model right now. It's got some really good roots, and it's got some generic things that you're going to be looking for, especially that you own your data, cloud service provider owns all the underlying infrastructure, but then you share everything else. So that's it for this lecture. Definitely do look for me on the next lecture. I'll see you then. Thanks. 1.3 on deployment models. So deployment models are kind of an interesting aspect of the cloud where we interact with this almost every day. So the big part of this test is compare and contrast the deployment models that you would use, and understanding the limitations that both you as the user and Azure as the cloud provider has when working with deployment models and how you do things. So the biggest thing to remember, again, as part of that shared responsibility model that we did in section 1.2 was to actually go back and take a look at who's responsible for what. As soon as you understand who's responsible for what, it makes it a lot easier to determine architecturally and from the user viewpoint on exactly what do you want to do and how do you want to do it within the cloud. So as you go through and you take a look at these things, like infrastructure as a service is probably the most flexible. It's the one you're going to be the most comfortable with because it's the one that looks the most like your on-premise data center. You are responsible for everything except for the underlying hardware and networking in the Azure data center. You're going to be mostly working in virtual machines, but you have firewalls, you have network switches, virtual switches, networks as in virtual VPCs, virtual private clouds, operating systems. You are responsible for all that stuff, including your licensing, right? So, but the good part is instead of buying the hardware like you would underneath CapEx, you turn this into an OpEx expenditure, you rent it, and then you have an instant computing infrastructure provisioned and managed over the internet. If you're doing software-defined networking and you're doing it from that vantage point, it is literally an instant computing infrastructure, whether it's high capacity, whether it's machine language and AI modeling. You literally can instantly have a computing infrastructure that you would not be able to get if you were doing things traditionally in your own data center. Platform as a service is probably something we're a little bit more comfortable with in terms of being able to rapidly build and test and deploy something from the process of creating your application quickly and not having to worry about the underlying infrastructure. So this is really good for your dev and test shops, but it's also really good where you actually have to have your own application doing things, but you just don't want to have to worry about the underlying infrastructure, including actually having to manage the operations of the operating system, updates, web servers, system updates, all that stuff. All that stuff falls onto the service provider to help you get to market quicker. So think of platform as a service as a complete development and deployment environment in the cloud that you can actually then use to service customers along the way. But the penultimate on this one is that software as a service. We use this every day, whether we realize it or not. Whether we use our Dropbox, we're using Netflix, we're using Amazon, we're using Office 365, Dynamics CRM, Salesforce. All of these right now are software as a service, and we use these every day. These are really common. Teams, everything else, Zoom, all that stuff in the cloud. So it's centrally managed and hosted for the end customer. You're simply using someone else's software, and all you're worried about is your data. You can pull your data down, you can move your data around, restrict access, do all those things that you would normally do with data, but you don't worry about the application anymore. You don't worry about who manages it. You don't worry about updates. You don't worry about the underlying infrastructure. You're just simply using someone else's software. And this is a really common deployment model. A lot of services geared towards customers is there because customers can do a lot less damage. In terms of putting malicious stuff in. It reduces your exposure in your endpoint, so there's some really good trade-offs on the security side. But software as a service is where we spend an awful lot of time now in terms of using and consuming cloud resources. Now, the interesting part, though, is that there's some other services that are up and coming, and these may or may not be on the exam. But one of the things you really do want to watch out for is something called function as a service for your serverless environment. We'll cover serverless environments as we go through this, whether you're working in a container system like Docker or Kubernetes, or however you pronounce that word. I'm going to use Kubernetes on this one because that's how I learned it. But again, function as a service. That's where you are pulling functions and runtime, just like you would in a regular program on your computer. And you're doing this as one thing, whether it's a message queue, whether it's a function to do a thing, whether that's on an image, some process, parsing a log file. That's all these functions as a service. And there's a very big, robust API set in Azure for this. So this may or may not be on the test, but do look out for FAAS, function as a service. One of the other things I thought was interesting too is they do bring up XaaS, anything as a service. So this is generally a category of service that's really more aligned to IoT, Internet of Things. It recognizes all the data coming in. It's great for feeding a data warehouse. So if you need to do big data analytics, if you want to do machine learning on a big data analytics pool, and you want to work from messages or you want to work from some other data packet, whether that's roadway information or thermostat information or manufacturing process and control, you might see XaaS. And it is just anything as a service. It's just a general category. It just is related to cloud computing and remote access. It just recognizes there's a lot of data that can come into the cloud, and you can do neat things with it in a data warehouse, in a data mining, or in a machine language and modeling training kind of process. There's also some other things too, because marketing people have gotten involved. Other services. You're going to see these maybe pop up. These won't be on the test, but just something to kind of remember is that everything now as a service is really becoming a thing. And it's interesting that it's becoming a part of the process. So disaster recovery as a service, communications, networking, blah, blah, blah. So software-defined networking as a service. These are all things that you can get and use and otherwise work with in terms of those other services. So as you compare and contrast those services, and this is part of the test, compare and contrast, and you'll see this a lot in there, right? Cloud computing types are a service deployment model that lets you choose the amount of control over the information you have and the types of deployment that you want to do and the kind of services you need to provide. So you've got to remember that there are three main types of cloud computing services, sometimes called the cloud computing stack, because they do build on each other, right? The first cloud computing type is The first cloud computing type is infrastructure as a service, which is used, basically internet-based access to storage and computing power. Second is platform as a service, and that's where you build your tools and you're hosting your web applications and you're doing all that neat stuff. And then third one is software as a service, which we use every day as part of that process of just consuming someone else's stuff to do a function or do work, whether that's customer relation management, watching a Netflix video, or up, down, loading stuff from Dropbox, or even working in Microsoft Teams or Microsoft Office. Now, what's interesting about the outline for this exam is that they actually ask you to choose services based on use cases. So that means there's going to actually be some scenario questions in the exam. So they're very clear in calling this out, and it's very highly likely that you will get scenario questions. So there's some really good ones in here that you can go and pick and pull and practice from. So sort of like the scenario where you have 10 application servers and 6 servers are this kind and 2 servers are this other kind. What's the best model for payment? And again, when you take a look at something like this, make sure you're getting the best cost savings for your company. If you have something where you know that you're doing a fixed pricing model, right, reserved instances for that first scenario is the right way to go. If you're a printing company and you want to expand globally and you want to give your customers a limited portal, your customers will be working as software as a service, where you can also do it as platform as a service, depending on how much you need to have for your custom application. So you could give your regular customers software as a service. They upload their picture, they pick out what they want to do, they do some minimal cropping, they send it off to the printer. The printer works on platform as a service, so we can actually integrate with the printing presses, send that over via an API, and then boom, out it comes, and then it gets mailed, right? So you can mix and match these services as well. You don't need to specifically stick with one. So be really conscious and aware that the test is going to ask you for scenario-based use cases. And we'll be covering a lot more of those as we go through this. This is just to kind of get you used to that expectation and those cloud service delivery models. So thank you for attending this lecture. I will see you in the next lecture. For this section on cloud deployment models, there's another way of looking at cloud deployment models in terms of how you deliver services. And part of that has to do with architectural viewpoint and what kind of cloud you're going to buy. So what's interesting though, and I find this really kind of remarkable, is that in the test outline, they're actually asking you to define cloud computing, like we were defining what is Azure. that basically what we're doing is we're saying that cloud computing is a way of turning computing power into a service that can be accessed by anyone on the internet. You have a credit card, you can go do your thing, go have fun, go build something wonderful. Right? And there's all these new services, software. You have whole new frameworks of work like CI/CD, continuous integration, continuous development, or continuous delivery. We're still uncertain as to what CI/CD actually fully truly means. But again, cloud computing is that big shift from that traditional way we do business. So with our on-premise data center where we're going out and we're buying a bunch of equipment and praying we get it right to build our new service. So where you just go out, boom, there you go. You go and you do your thing. You can rent it, build it, buy it, do whatever you want to do with it as you go through in the cloud. So that's really what the cloud is, and that's why I call it a very democratizing service. Anyone can do anything. So Azure is a public cloud. All right, anyone can purchase and use these public services. This is Amazon, this is Microsoft, this is Google, Alibaba. All of them provide a realistic public service. You can go buy whatever service you need to have, right? And public clouds are owned and operated just like any other third-party service provider, whether that's Dropbox or whoever, right? And they will deliver whatever you need over the internet. And Microsoft Azure is a perfect example of a public cloud, right? And again, all the hardware, all the software, everything is owned and managed by your cloud service provider. So that's your basic definition of a public cloud. Now, private cloud though is a little bit more different. This is your data center or a data center that you have virtualized using VMware or other products. And it's a way to just extend out that data center to try to take advantage of the hardware better or more, be able to handle peaks better. So it's still your stuff. You're still responsible for it. You're just using something to make it cloudy. You're using whether it's a VMware or something else. Some people pay third-party service providers to host their private cloud. You'll find that there's a lot of third-party data centers floating around that you can go do things in, right, and not worry about it as you go through for your private cloud. Then your hybrid cloud, and that's a combination of public-private, right, where I may have all of my data storage in my local data center on a network-attached storage with a cloud gateway of some sort that allows me to process that data over the cloud as part of a data warehouse. So that combination of public-private, whether it's connecting straight through a VPN, connecting through some direct connect service or peering model, right? This is just a way of combining that hybrid cloud of using bits and pieces of both kinds of clouds, public and private, to suit your business needs. These can be a lot more flexible because it still gives you control over some of the things that you may regulatorily need to have control over, either through regulation law or just whatever business you're in. So they do ask you to compare and contrast these. So be aware that this is going to be part of that scenario question process. So in that you go into those cloud computing types, the service deployment model lets you choose a level of control of your information. So that's your IaaS, PaaS, and SaaS. And then you have where that information actually resides, whether that's in the public cloud, a private cloud, or some hybrid model, right, as you kind of go through that. So you're going to work out and compare and contrast those two things because they really do go hand in hand. You may do infrastructure as a service and using a hybrid cloud delivery model for that because you can do a direct peering. You're close enough to their data center that a peering arrangement really makes sense. And again, it all just boils down to your architecture. So really quick on that one, those cloud deployment models are interesting when you see how they all tie together to help you make a better architecture for whatever service that you want to have. So thank you very much for attending this lecture, and I will see you in the next lecture on serverless computing. So in this section for the AZ900, it's really generic in terms of what we want to do, and we want to talk about this. The one thing that you do need to make sure you know is that you understand that serverless computing enables developers to basically build applications faster. There's literally zero infrastructure here. It's all based on containers, right? And while you still have a server and all the other things underneath it, to the developer's viewpoint, these things don't exist anymore. I'm just going to write code and then see if it runs in some kind of environment. The cloud service provider is going to scale, provision, and manage all that infrastructure required to run that code. These are very small little code sets, right? You're not going to put Microsoft Office or something huge into a serverless computing environment. Think about more of these like one-off production ideas. I want to change a picture. I want to resize something. I want to do a thing, right? And you'll see this tied to function as a service as well. So it's really important to understand the definition of serverless computing. Servers are still running the code. It's just invisible to everybody. No one's going to care that the infrastructure is being provisioned by the cloud provider. So this is really an interesting way of taking a look at the cloud, and that it abstracts things way up into the software development side and is really much more geared towards developers getting code out to customers quicker, right? You can build, test, break, test, get to production ready, and then go. And slide that new code set in without changing any of the business logic or being able to change anything along how that person or how that process works in terms of workflow. It's just that it's going to work better if you have really good developers doing this. So it's really important to understand that part of it. One thing that's driving this is what's called serverless Kubernetes. I'm using that word, Kubernetes, as I have learned it. There's a lot of different ways of saying it. Kubernetes, oh my goodness, the thing that goes along with Docker. So lots of different ways of saying it. I'm just going to use Kubernetes here because that's how I've learned to say that word. All right, but it's essentially, in Azure, you have the Azure Kubernetes service, which is just basically a bunch of containers. And each one of those containers will run functions that will do a task. And that's exactly all it does. That is exactly what a serverless environment is. If something happens, it goes over to that Docker container or that Kubernetes container, does its thing, then shuts it down. And that's all it is. You're going to see something that's called ability to scale to zero, and that if you're under heavy loads, your system will automatically scale out as much as you need. But the cool part is that a scale to zero means that when that service is done being used, it can turn itself off. So you don't have to worry about it running or having to have something in the background running, right? It will only run when it's needed to do the things that it needs to do. So this ties into, again, that function as a service model. And this is why I'm thinking it's going to eventually show up on a test somewhere. Because again, these are serverless functions. You're going to be executing code. You can write it in any language that you choose, right? One of the most popular right now on any platform is Python or PHP. Those two, really big. But you're in Azure, so you're going to be writing in C#, you're going to be writing in .NET, you're going to be doing all those things. So again, depending on your language of choice, you can just go ahead and write your function and go. These are event-driven computer experiences. So you can scale on demand, you pay only for the time your code is being executed, and it can be a managed service as part of the Azure stack. And there are a lot of functions that go along with this that you can actually pre-buy, pre-packaged, including those Kubernetes containers that you would run these things in. So as function as a service and as that whole serverless environment, it's really about the applications, right? It's that serverless application environment where you're running and scaling. You can put WordPress on that. You can do all sorts of things, but you're running it on the platform of your choice. And it really is a more productive way of doing things because you scale code in small chunks. You just have to be really aware of the interdependencies of how that code scales and how message queuing works. And we'll work with that as you go through. But if you want the fully managed experience, you're going to go with the Azure App Service. And we'll talk more about that app service as we get into that. So that concludes the idea of serverless computing. It's a relatively new but very neat way of doing cloud computing along the way, and really takes advantage of those economies of scale that you would have, and supposedly, hopefully, if you have good developers, it decreases the pipeline time to actually fix something or get something working better because you're working with a small subset of the code, not the whole enchilada. Thank you for attending this lecture, and I will see you in the next one. With part one of this whole process. And remember that what we've just covered is about 20 to 25% of your exam. So really understanding these things as you kind of go through it becomes all the more critical because again, this can make or break your exam. So we're just going to kind of summarize what we learned in part one on this. So in this, we described cloud concepts. We reviewed common terms like scalability, elasticity, agility. We talked about some disaster recovery processes. You really do want to know the difference between CapEx and OpEx. We identified some differences, some tax advantages for which way you want to go in using this, and that overall cloud computing can help you reduce capital expenses, but it will increase your operational expenses. So make sure that you understand that trade-off. Right? We discussed the consumption model where you're charged for what you use. This is pay-as-you-go model, right? That's another way. So consumption and pay-as-you-go are the same thing. And then the shared responsibility model, where you're always responsible for your data and who accesses it. But depending on what delivery you do, whether it is infrastructure, platform, or software, defines how your cloud service provider interacts with your data and the things that you're responsible for and the things that they are responsible for. And this is a big underpinning for the cloud. We also discussed the three kinds of cloud service delivery models: infrastructure as a service, platform, and software as a service. We also looked at some of the upcoming cloud service models: FAS, function as a service. XaaS has actually been around for a long time, but it's still kind of in the dark there a little bit, but it's mostly associated with IoT and other kinds of services. We also reviewed serverless computing to streamline business logic. We reviewed 2 scenarios for moving into the cloud to kind of take a look at how you want to do it with our printing company and our people that were doing other things with our D services. And we defined the term cloud computing. Interesting enough, that's something they do want you to do. And then we looked at our different kind of deployments: public, private, and hybrid cloud deployments. So definitely do make sure that you have all that. And I will see you in section 2 of this file. Thank you much.